Okay, in this video, we're going to talk just a little bit about scale factor, and in order to do that, we're going to start with a proportion review. Okay, let's say that we know that the ratio of girls to boys in the class is 7 to 6. So I'm going to write down girls to boys. 2 is placed for my fraction bar. So then I have 7 girls to 6 boys. Okay? So I'm going to keep girls across all the way on the top, boys across on the bottom. So I'm going to make a proportion then to determine how many boys that I have. And this is a relatively easy one, but this is just a review so we can remember what to do. So I have 49 girls to how many boys? So 49 girls to how many boys? Now, I can do this one of two ways. You can either cross multiply because the product of the means is equal to the product of the extremes. So 7x equals 6 times 49. Now, the other thing I can do is I can say, okay, these represent equivalent fractions. This ratio and this ratio have to be equivalent. So what do I do to get from 7 to 49? I multiply by 7. So if I multiply the denominator by 7, then x would equal 42. So a ratio of 7 girls to 6 boys is the same as a ratio of 49 girls to 42 boys. Again, remember, keep the same thing across all the way. Now, let's go to and apply this to triangles, congruent triangles, or actually not congruent, but similar triangles. Now, notice the difference. A similar triangle is just the little sideways S with no equals under it. Sometimes that's also, typically that's approximate, but I've seen that used as similar in some books. Typically, this is not something I do, but I have seen some people use it. So, I want to know about, I've got two triangles here, and they're similar in the order that we have. So we've got A. In similar triangles, remember, the angles are congruent. The sides aren't, but the angles are. So A is congruent to E. Okay, B is congruent to D because it's in the same location, and C is congruent to F in the same location. So the ratio of the large triangle to the small triangle. Okay? Now, think about this. What is the scale factor if we look at, we have to identify the scale factor first. In other words, what can I do to the large sides to get to the small ones? Okay, what do I do to get 16 to get to 8? Divides by 2. Let's see if that's true of all the others. 4 divided by 2 is 2. 8 divided by 4 is 2. So the scale factor of large to small is 2 to 1, or 2 over 1, or 2. Alright, now if I look at small to large, what do I do from small to get to large? 4 times 2 is 8, 2 times 2 is 4, 8 times 2 is 16. So small to large is 1/2. In other words, small, large. Large is twice as big as small. So it's the same thing here. So large to small is 2 to 1. Small to large is 1 to 2. So keep in mind, the small one is little, the large one is twice as big as the small one. And so that works for each piece. Okay, now let's take a look at this one. Let's say that I have my original triangle, ABC, and it's similar to triangle DEF, and I've marked up the what's congruent to what. So let's say we've got two problems here. Let's say the ratio of the small to large is 1/2. Alright, small to large to large. Okay, so that means small to large is 1/2. Small's on top, large is on the bottom. Small, large. Okay, so then I take the small side. So if the small side is 9, I'm going to be doubling it to get this one if I'm talking about this particular thing. So in that case, the side AC is 9, so its similar side is DF, so it's 9 times 2 because the large one's twice that. So it's 18. So the sides here then, this one would be 18, this would be 10 times 2 is 20, and this is 6 times 2 is 12. Now likewise, what if the ratio of small to large is 3 to 1? Oh, excuse me, large to small. Large is 3, small is 1. So in other words, the small side, I divide the big side by 3 to get this one. Okay, so if I want to know this one, then I have to do the opposite, which would be to multiply it. So if the ratio is 3 to 1, then the small triangle is 9, so the large one's 9 times 3 is 27. The small side is 10 times 3 is 30, and the small side is 6 times 3 is 18. So that's kind of a review of similar triangles and proportionality.